we get out here?
11:08. We have 27 minutes. So
Extreme?
this extreme values. This is extreme. It's like, yeah. Right. Find some values and bullshit. Okay. No, that's not what it is. That's just the whole chapter 5.
How crazy they think we were.
Like chapter 3 and chapter 4, all we did was like figure out how to do derivatives. Product rule, closure rule, chain rule, sines, cosine, all that crap.
What's that?
Factoring cubic, sum and difference of cubes.
Something we never do.
Yeah, we didn't need.
Awesome.
What was I talking about? Thanks for
About extreme stuff.
extremes. No, this is just the first section. The whole overarching chapter is about taking derivatives and applying them to things. The first 2 sections are just applying them to graphs and functions. Kind of boring, but you have to be able to do that before you get to the word problems, and it applies them to like stuff like the classic, like if a train is going this way and one is going this way. There's that, or a lot of stuff with medicine, like if you give a patient medicine, you can figure out the proper dosing.
Stop, I don't want to think about
It's all
that.
calculus.
I just read word problems, it's like, why would I care?
Yeah. One good thing is, what is the most effective size for a dose of medicine? That's one of the questions they ask. What is the least expensive way to pipe oil from an offshore well to a refinery down the coast?
I'm not doing that either.
You are in a few weeks, so
Well,
we'll get there.
not
But these first 2 sections are just little things, little pieces to build on it, and by the time we hit chapter 5, it gets crazy. Or section 5.5. That's not chapter. We are chapter 5. So we just start with this little stuff, and it doesn't seem bad if we just go little by little. Eventually, if I because I looked at the test just right now, just to remind myself, and I was like, "Ooh, yeah, that's good." But this is the biggest. I have a big binder, just to give you the idea. I have a big binder over there of all the notes from last time I taught the class, and it's about that thick. Chapter 5 is about that much. For the video people, it's like half of my notes are chapter 5. It's just a lot of stuff.
So we should open new notebooks.
Yeah.
Right.
So over your 4-day weekend,
I gotta
get yourself a fresh one.
3
So just
subject
gotta
ones.
add some.
I'm on the third, don't have like. your
Okay.
calendar.
Extreme values. What do you think that means of functions? It's not really just like ones that are crazy.
When you say extreme, I think of like ramps.
Ramps. Good. That's kind of like, because a ramp, it takes you higher, and then there's a highest point, right?
Or like on cartoons.
The
where
top
there's,
of the ramp is the most extreme.
There's like 2 ramps, and they put like a ring of fire in the middle. And that's
Oh, yeah, that's
I don't know.
I think of extreme
Great
surgery.
visual.
Right?
So extreme values are just, let's say, good classic example is a good old parabola. Any old parabola. There we go. I don't know what the equation is. But we have things called, they're called absolute values. You could have absolute minimums or maximums. And it's just the highest and lowest points that a function takes on, basically. You can call it absolute or global. Those are the same thing.
We got to.
So let's say this is 2, 1, 2. Let's just go like that. Oops. This one will be tricky. So if we have that weird parabola, I don't know the equation, I just made it up. This parabola does not have an absolute or global maximum. Why do you think of that? Because it keeps going up forever, yeah. So there is no maximum because you can just keep going up. But it sure has a minimum, doesn't it? And where does that minimum occur? 2, 2. At x equals 2. So you would say this one has a, you could write, these are interchangeable, global and absolute. And usually when we're talking about global or absolute minimum or maximum, we just say minimum or maximum. We don't always do it. There is another kind called local, which is where you're just looking at one little spot. But we'll get to that next week. But for now, it's just overall. So we can say this one has a minimum, and I always abbreviate, minimum at x equals 2. And if it asks for what the minimum value is, you can say y equals 1.5. could write it as, this is better, minimum at 2. Let's do that. Let's put the whole point. Sometimes if I just ask you for x. So that's it. That's 5.1 basically. Of course it gets trickier. Let's do this. Let's do y equals x squared. Draw that. Just we can restrict the domain when we're talking about maximums and minimums. For example, I'm kind of going on the screen. If I say over the domain, over the whole domain of this thing, so just you're looking at the whole overall picture. We are just like the last one. There's no maximum, is there?
No.
So you can say, I'll just make a little chart here. And these are called extrema. Weird word, I know. Extrema is the word for maxes and mins. It's extreme values, extrema. It's just a way of saying the word. I don't know. It's just like what? Yeah. So when the domain is all reals, when we're looking at the whole picture, we said there was no max, right? Max, we'll say none. Is there a min?
Yeah.
Where?
X equals 0.
At x equals 0. So you can say there's a minimum at 0, 0. That'd be one way of writing it. You can say there's a minimum of 0 at x equals 0. That's another way of writing it. All means the same thing. But like I said, we can restrict the domain. So now let's say, instead of talking about the whole thing, I just want to talk about the part from 0 to 2. Notice I use brackets instead of parentheses. What's that mean?
The x values.
Includes, yeah, the x values. So if I go from 0 to 2, I'm just looking at this piece right here. What's the y value at that point? That's 4.
Oh, x squared.
Good old outdoor question. Go in. 4. Okay, so does this, if we are just looking at that piece now, does it have a max?
Yeah.
Yes. What is it?
2, 4.
Yeah, max at 2, 4. Does it have a min?
Yeah.
0, 0.
0, 0.
Yep, that's it. That's how this works. It gets a little changes a little bit if you don't include the points though. Like, let's say I go from 0 to 2, like that. You know what that means?
The minimum is 4.
The max is still the same, still 2, 4. But now the min is different. Because, right, this would be open circle now instead of closed, so it'd be just that. Yeah, that's weird, huh? You can't do it. There is no minimum. Because you could always go a little bit closer to 0.
Yeah.
Like you could say, oh, it's at 0.0000000000001. And I go, nuh-uh, it's at 0.000000000000001. And she's like, nuh-uh, it's at 0.2. And you can always go smaller. So there is no minimum.
I know.
Just do it enough times to get the point across. You can always get closer so it doesn't happen. And so then, using that same idea, if I said from 0 to 2 like this, so if we were just looking at that.
Do you need both of them? Oops. Wouldn't it have one?
Yeah, there's none. There's neither. There's no max or min. Just leads us to the extreme value theorem. f is continuous on a closed interval a to b, then f has both a maximum value and a minimum value on the interval. That make sense? Well, one day those will make sense to you when you read this stuff. You'll be like, no, that makes sense. I don't know if that day is today. This one might, if you actually looked at it, read it slower. It says f, if f is continuous. F is just a function. So we've got a function that's continuous. You should know what continuous means, right? No holes or breaks or jumps or anything. It says on a closed interval. I'm going to write the words and you're not understanding much. On a closed interval a to b. Well, what's that part mean? On a closed interval a to b? Yeah, it has endpoints and it includes them. It doesn't go on forever, it's on an arrow, so it's not my whole parabola. It's just a section of it with endpoints. If you have a function that has that, then there is going to be a minimum and there's going to be a maximum. That's all it says. There is
I was addicted.
there exists both. That's it. That's all the extreme value theorem says.
It makes sense.
That's just what we did.
Yeah, it is what we did, but it's just like in words what we did. There will be both if that happens. For any function that is continuous. That's dumb, but that's going to come up as the answer to a question sometimes. Like prove that, and it'll give you a bunch of graph, and you're like, oh, I know how to prove that by the extreme value theorem. That has to happen. And that's the answer to questions sometimes. So it's weird. Okay. What's next? Now we're going to find extreme values. This is the hard part of the day.
And then,
Extreme values of functions. So without looking at the graph, we're going to be able to find extreme values. So we'll start with the basic and easy one that we already know. Just to prove something here. Y equals x squared. Okay, here's the hard part. Let's see if you can come up with this. First, do you know what an extreme value is?
Just
Minimum or maximum. It's the highest or lowest point on a graph, right? Okay. Where does that happen on a graph? Just in general. How do you end up with the highest or lowest point? Give it to me. A vertex. And what happens? Give me some math in there. Without thinking about it, what
the
happens?
slope changes from negative to positive.
That's it.
No.
Black out for a second. Yeah, the slope is going to change. On this one, the slope changed from negative to positive. Or what could happen? Change from positive to negative. The slope changes sign, right? And when that happens, you're going to end up with either a hill or a valley. And that's going to be a maximum or minimum. And it doesn't necessarily have to be like a parabola where it's that. You could have like this. And we're going to find these ones too. We're going to call that a maximum and that a minimum. Those are going to be later. That's local rather than global. Later. But we're going to find all the points where the thing turns around and gives us a maximum, an extreme value. Okay? Maximum and min. So how are we going to find, see how good you are, how do we figure out where the slope changes sign?
Where x
you
is
find the derivative of the original.
Find the derivative of the original.
And plug in 0.
You're geniuses. It's going to be all right. We'll take
This
it.
is what happens when we get good grades. We feel
It's
better.
because we're all happy because we got
You know?
Yeah, if you do the derivative, y prime, you get 2x. And this one's really basic, so it doesn't really look cool. So that's
It looks extremely cool because it's basic.
This is basic. And like what I said, if we set that equal to 0, 2x equals 0, divide by 2, so x equals 0. X equals 0 is where that thing, that derivative is going to change sign, right? Does that make sense?
Yeah.
So all we have to do now is figure out, is this a minimum or maximum? How are we going to do that? This one we know the answer, because we can picture it in our head. But if we didn't know the answer, mathematically speaking, we know the slope changes sign at 0. So how do we know if it went from positive to negative or negative to positive? Plug numbers in, that's exactly right. Sometimes you're going to have more than one answer. Just basically though, think of this as a number line, and at 0 is where my slope changes sign, right? So what's happening to the left of 0? Well, let's pick a number and plug it in and find out. If I plug in -1 to my slope equation, what are my slopes here? Negative. And if I plug in +1, I have positive slopes. And I like to draw little things, so my slope changes from negative to positive, so we have a minimum. At 0, and if I plug it in, it's 0. That's right, I know it happened at the x value of 0, so I plug that into my original equation for the y value. Let's kick it up a notch. By a notch, I mean several. We just went from the most basic and easy one to one. Yeah. So let's find the extreme values of that. I have no idea what that graph looks like. Neither do you. So we find the derivative. Oh, how do we do the derivative of 1 over x? We put it as x to the -1. ln of x will leave alone. Now we can do the derivative of that. So we have -x to the -2nd. What's the derivative of ln of x? 1 over x. Plus 1 over x. Not yet. Right now we have to figure out where it changes sign. So what happens when something changes sign? It has to cross through 0, right? That's why we set it equal to 0. Because if it's one side or the other, then it's going to have to change sign.
What if it changes so when it's like not at 0? Like you know how you do it with me, but if it's not like at 0.
You're going to get a different number for x. Okay, you're saying, I know what you're thinking. You're thinking of the original function, setting that equal to 0. The derivative is the slopes. This is slopes. When I plug in numbers here, I get a slope for an answer. So if I set that equal to 0 and solve for x, that'll tell me the x values where the slope will be 0. Does that make sense? So if you know where the slope is 0, then you could go on either side of it, and it has to either be positive or negative because it's going to change directions. Right? Because 0 is where it's flat, unless it just stays flat, but then we know because it would just be a horizontal line. It's going to be some kind of curve. It's going to hit 0. The slope is going to hit 0 for just a second. And those are the points we're going to find by setting that equal to 0. So we got to set that thing equal to 0 and solve it, which doesn't look fun. This is why we did pre-calc. Kind of. You can laugh, it's okay, it's fine. She just looked at me. God. How do we solve that? I don't like negative exponents. I don't know about you, but I'm going to go like that. And then, common denominator. We get x squared. That one's going to stay the same. That one gets multiplied by x. Should have that. Multiply by x squared. So now it should be easy, right? Multiply this side by x squared, still stays 0. So So we just have -1 plus x equals 0. X equals 1. So what does that tell us, Brenda?
I don't know, don't ask me.
Okay. Katie, you know, what's that tell us?
Children.
I know.
Okay, but
Oh,
what
where
does
it's
that
going to
tell us?
change.
Why did we just get x equals
Where
1?
it's going to change.
Where it's going to change, yes, that's acceptable, I guess. It's where the slope equals 0, and that's where it changes, right? It changes sign.
Mhm.
No, it's good. We have to talk a lot in this section, because the more you talk about these things and say them, the easier it is. You guys are gonna have to come up to the board during this and like talk problems out and teach the class how to do a problem. Because it helps so much to talk and say it.
No.
And we're gonna make flashcards too about all these
We're
things.
gonna make fun of you.
Maybe a little
I'm
bit.
getting out of this class.
Tiny bit. Okay, so this is where the slope changes side. So now we have to figure out
Changes what? Will change size.
sign. Positive, negative, or negative, positive. Where it equals 0. So this is where I put a number line. Right now it's easy because we only have one point. In the future there will be multiple. Right now we have one.
I'm not gonna on you.
And this is, I should label this. This is like my signs of
Not you.
slopes.
You did it what? We didn't talk about it, and then, so, everything's so good out of it.
So to the left of 1,
Tell him, just give me out.
Plug in.
plug in what? Probably 0. Let's see here though. Here's my, what's that called? Slope function, right?
Yeah.
I don't like plugging in stuff right there. Isn't this the same thing right here?
Yes.
I like plugging it into there better, don't you?
-1 over.
So if I can't plug in 0,
-1.
why not?
Because you can't.
There's no slope there.
-0, not -1.
So let's just plug in, what, a negative number?
-1.
Here's the thing too, you don't have to calculate these perfectly. If it's ugly like this, just think, if I plug in negative whatever, what's the sign of the top going to
Negative.
be? Negative. And the bottom is going to be a negative squared, which will be a positive, so what will be the sign of the slope? It's going to be negative over there. You can plug it in and calculate it exactly, but sometimes it's just so ugly you don't feel like it, so you can just, all you care about is signs. And if I plug in a positive number bigger than 1, so like 2, well this one, 2 is easy to plug in, right? 2 minus 1 is 1, 1 over whatever, who cares, it's positive. Yeah, 1/4. So what does that tell me now?
And
Why did I just do that?
because it tells us
It
where
tells
it
us
leads.
for minimum
Coming
is
from.
that.
It tells if it's a minimum or maximum. How'd you know, what'd you say it was? Is it a minimum or maximum? I thought you said.
I just said it tells you what the minimum is.
Oh, what if it's a maximum?
I don't know.
How do you know?
It's a
I don't know.
minimum.
Draw yourself a little picture. What's a negative slope look like?
Going
Going down, positive slope's going up, so this one is a minimum, that's 2 minimum. If it was a positive, if it was a max, you would have seen, you would have got positive over here, negative over here, because then when you draw it, it's positive to negative, that would have been a max.
Oh.
That'll happen if it's a max. I just did 2. Once again, bad example, should have done one of those. So this is max at where 1 what?
I thought it was a minimum.
Oh, minimum, yeah. Jeez, I'm talking too much. Minimum at
We're really start
1.
getting when you throw that in there. It's gonna be.
You just leave it at
We're
X.
like finally starting to like get there, and then you finish like that.
Well, how do you get the point right here? Max, minimum at 1 comma what?
X into the.
Plug it into. See, this is where this is where people mess up.
The original.
The original tells you the points on the graph. This one tells you the slopes.
Where to put, just X equals 1?
As of right now, no. Let's get the whole thing.
We're always like, so the acceptable answer.
The acceptable answer now is the whole thing, so you have to plug 1 back into
Plus
this.
ln.
1 plus the ln of 1. Anyone know what the ln of 1 is?
Is that calculated?
It's something
10.
really simple.
10.
It's log base e of 1. It's a good review here. Log base e of 1. What's log base e of 1?
1 over
1 over
One
1.
over.
Oh, you're doing derivatives, you guys are crazy.
Oh,
I
yeah.
just want to know what log base equal 1 is. This means e to the what power gives me 1.
1.
E to the first power is e. E to the 0 power is 1. So we have 1 plus 0. The answer is 1. 1, 1.
Can we use calculator?
You can use a calculator, except on the problems that say no calculators, which would be this one. So no, it does have a box.
No time for more.
No, I know. I gotta give you your homework.
Leave it out.
It's 5.1. Long weekend, so this is gonna be a little longer than that. Quick review, 1 through 12. And then 1 through 4, 6.
You can't even see
You can't
it.
see.
So what you're saying is,
Kill yourself over the weekend. What you're saying is wait till
after
Tuesday.
this
to do it.
period, I'm gonna
It was either this or I would make YouTube videos over the weekend, but nobody enjoys that. Not me, not you.
I mean,
And then you guys are looking for it, and then like Monday night if I post it.
Every day.
so we go to.
Yeah.
Do I turn this off?
1 through 8,
Yes.
or 1 through 10, you're looking at graphs. And then the rest you're doing with the functions like I just did. So you'll have to do a lot of derivatives. Yeah, you can.
Yes.
This is weird.